All right, today's notes is on 11.2, experimental and theoretical probability. I decided to do another handout with this lesson. There's a lot of words to write out, and there's not a lot of work to do these problems. We can go through this lesson pretty quick. If I'm not taking the time to write it down, or you're not taking the time to write it down, you are welcome to write it all down yourself. If you don't want to pick up a copy or you don't want to print out a copy, your choice. I'll leave it up to you. But talking about probability, so we could have an impossible event or situation. So the probability that would happen is 0, because it can't happen, or 0%. We can write things as a percent or as a number between 0 and 1. So the probability of a certain event is 1 or 100%. Like I just said, otherwise the probability of an event is between 0 and 1 as a decimal, or a percent between 0 and 100. We can also write it as a fraction, not just a decimal, okay, which is the way we're going to write our answers today. So we'll talk about experimental probability first. You probably did things with experimental probability in middle school. Maybe they had you like roll a die, flip a coin a bunch of times, you make tallies, and when it lands on heads, when it lands on tails, and you perform these different experiments to figure out the probability. We're not going to do any experiments, but this is a fraction bar right here. So on top would be the number of times the event would occur that the problem is asking for over the number of trials that were done in the experiment. Okay, so this first example below, so a softball player, okay, got a hit in 30 of her last 50 times at bat. Okay, so what is the experimental probability that she will get a hit in her next time at bat? So we're basing the experimental probability over the situation that has happened. Okay, she had 50 times that she tried this, so 50 trials. And then how many times did she get a hit was 30. So 30 out of 50 would be her experimental probability. Now I was looking through the homework on Math Excel. All the problems I saw, I'm pretty sure it asked either for an integer or a fraction in simplest form. So an integer is not going to be a decimal. So we're not going to put any decimals in there. So you're going to write your answers as a fraction. So make sure you divide each by 10, and we simplify this because it'll mark it wrong if you do 30 over 50. We need to do 3 out of 5, the simplified form of that fraction for the answer. Okay, so not a lot of steps, not a lot of work, just an understanding of what goes on top, what goes on the bottom for our fraction. Okay, 2 more examples using experimental probability. So this table right here for us is going to be our experiment that's already been done. So the number on top is what they rolled. So we're going to talk about rolling a number cube, is what they'll call it sometimes, or a die, right? So find the experimental probability of rolling a 2. So here's where they rolled a 2. How many times did they roll a 2? Well, they rolled it 12 times in this experiment that they did. And then I put it out of how many times did they do this experiment? How many trials did they do? So I have to add up 10 plus 12 plus 9 plus 11 plus 10 plus 10 to get a total of 62 trials. So that's how many times they rolled this die. Okay, and then that's my probability, but I'm going to need to divide both the top and bottom by 2. So 6 out of 31 would be the simplified form for my answer. Okay. All right, for number 3, find the experimental probability of rolling a 4 or more. So we can roll a 4, or we could roll anything higher, which would be a 5 or a 6. So we're in this section right here. So how many options do we have? I got to add 11 and 10 for 21. So 31 options, and there were 62 trials. And so I can divide both the top and bottom by 31. So 1 out of 2. Or yes, that means 50%. a lot of times I have my students write it as percentages, but I did not see many Math Excel problems or at all that ask for percentages, so just go ahead and stick with the fraction. Okay, so that's my experimental probability. Now we're going to talk about theoretical probability. It's not coming from an experiment. It's going to be what we would expect to happen or what would happen in theory. Right? You flip a coin, there's two sides. So probability of landing on heads would be 1 out of 2. That's theoretical probability. That's what we expect would happen. Does it happen every time? No, because it's by chance, but theoretically, we're going to calculate these next probabilities. So number 1, a bucket contains 16 blue pens, 32 black pens, and 40 red pens. You pick one pen at random. So I'm not sure if you've seen this notation for probability before. It has that capital P in front of it. That means probability. In parentheses, that's telling you what you're finding the probability of. Okay, so that means what is the probability of a blue pen? Well, there are 16 blue pens, and we need to find the total of all of the pens. So 16 plus 32 plus 40, we will come up with 88 pens. So theoretically, there are 16 of those 88 that are blue. And then I got to simplify this fraction, so I could divide both the top and bottom by 4. So 4 out of 22 would be my final answer. Okay. Next, capital P means probability. Probability that it would be black or red. So there are 32 black pens and 40 red pens. So the two of them together means that there are 72 options out of the 88 pens. Okay, to simplify this, I can divide both the top and bottom by 8. So I would get 9/11ths for my final answer. Okay. Number 2, suppose you spin a spinner that has, I have a typo on this one. Let's change that to 10. You have 10 equal size sections numbered 1 to 10. Okay, I didn't want 15 equal size sections numbered 1 to 10. Okay, so 10 sections, one number, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on that spinner. Okay, so part A, this means what is the probability that you land on a 9? Well, there is only one 9 out of the 10 sections, so 1/10 is my probability. I'll have a lot of students that will put 9 out of 10 because they see this 9 and they put that number on top, but that would mean that there are 9 9s in your spinner. That would be silly. Okay, probability you get a 13. Well, if we're numbered 1 to 10, there is no 13, so that probability is 0. So you will have some cases in your homework where it is not a possible situation, and that would be 0. Probability could be a 1, 3, or 5. Well, there are 3 options then out of the 10, since there could be the 1, there could be the 3, or the 5. So there's 3 spots that would make it true. D, what is a multiple of 5? So 5, 10, 15, 20, those are all multiples of 5. So 5 and 10 are the only ones that would show up on my spinner numbered 1 through 10. So that means there are 2 options out of the 10. And this one I can divide both the top and bottom by 2. So that would be 1/5. All right, so our last examples here. Find the probability of each event. So if I roll 3 on a standard number cube, that would be your 6-sided die. There's only 1 3 out of the 6 sides. Okay, number 2, rolling an odd number. I could have a 1, 3, or 5. So there are 3 options out of the 6 sides on my die. If I divide both the top and bottom by 3, 1/2 would be my simplified answer. All right, then number 3 and 4, take it up to a more difficult step. Now we're talking about getting a sum, so I have to add together the 2 number cube results. Okay, so if getting a sum of 9. So if I think about, I'm going to just kind of list my possibilities. I could get a 4 on one die and a 5 on the other. I could get a 5 on the first die and a 4 on the other. That's considered 2 different results because each die had a different number. I could get 3 on one, 6 on the other, or vice versa, 6 on one and 3 on the other. There would be no other options, so that means there are 4 out of, now think about how many there would be. We could list all of them out if you want to. I don't want to. But coming back to our previous lesson about using the counting principle, if one die had 6 options, and then we have another die that has 6 options, I multiply the amount of options together. So there are 36 options. Okay, I can divide both the top and bottom by 4. So 1 out of 9 would be my simplified answer. Okay, number 4 gets a little bit more complicated because now we're asking for a sum of 6 or less. Okay, so there'll be more possibilities because before we just had just 9, but it could get a 6, it could be 5, it could be a 4, 3, or 2. We'll never get a 1 because the smallest option we have is 1 plus 1. Okay, I don't write 1 plus 1 twice. If I have the same number on both, that is the only result. It's not distinct. It's not a different option. 3, I could get 2 and a 1, or a 1 and a 2. Adding to 4, I could get 2 and 2. There's only one time I write 2 and 2. That's the only distinct option. But I could get 3 and 1, or 1 and 3. 5, I could get 3 and 2, 2 and 3, 1 and 4, 4 and 1. And 6, I could get 3 and 3, 2 and 4, 4 and 2, 5 and 1, 1 and 5. Okay, so if I find all these options, I've got 5 options here. I've got 4 options here. 3, 2, 1. What a cute little pattern. So 5 plus 4 is 9, plus 3 is 12, 13, 14, 15 options out of the 36 results. Okay, so I can divide the top and bottom by 3. So I'd get a 5 over 12. Okay, that is it for our lesson. It doesn't take you long to do these problems. You're just coming up with that fraction. If you have to simplify it, simplify it. If you don't, type that fraction in as your answer. Hopefully the homework will go pretty quick for you. There are quite a few problems, I think a little over 20, but like I said, they do not take long to do. Please reach out if you've got any questions.